In this video, we are going to discuss about a problem based on source-free series RLC circuit. The question is find the I of t for the given circuit. So the I of t is flowing in this direction. Okay, and assume that the circuit has reached the steady state at t is equal to 0 minus. So at t is equal to 0, the switch is opened. So before that is t is less than 0. Okay, that is a case, right? At t is equal to 0, it is open circuited. Before that one, it is closed. Okay, so if it is closed, then at t is t is equal to 0 minus. So t is equal to 0 minus, what I should do, you have to, if I have a capacitor, I need to short circuit the capacitor. Okay, sorry, open circuit the capacitor. I need to open circuit this capacitor. And if I have an inductor, I need to short circuit. So okay. So if I open circuit, there is no use in drawing this one, right? So this is your EC of 0 minus. So okay, and the current flowing through this inductor is I of 0 minus. Okay. So this is your 10 volt. So you can see I have a 10 volt DC sources in series with 4 and 10. So the current flowing through this one is I of 0 minus is 10 volt divided by 4 plus 6, that is 1 amps, right? And I need to find the voltage across this one, right? This capacitor. So if this is open circuited and the current flowing through this one is 6, current flowing through the 6 ohm resistance is 1, right? So the voltage across this one is 6 volt. Okay. So if VC of 0 is equal to 6 into 1, that is 6 volt. So this is nothing, VC of 0 plus also. Since there won't be an abrupt change in the current and current in the inductor and voltage in the capacitor. Okay. So this is at t is equal to 0 minus. So at t is equal to 0. At t is equal to 0, you can see this is open circuit. If this is open circuit, it means what will happen? The circuit will look like this. So this this 10 volt source is entirely disconnected from the circuit. So this will look like this. Okay, so I'm going to redraw this here. So this is 0.02 farad. So I need to find the I. Then this is your 6 and they have 0.5 Henry, and this one is 3 ohm. Okay, so now you can see I have RL and C. Okay, so these two resistors are in series. Okay, so you can see RLC are in series, and it is source free, right? It is source free. There is no voltage source or current source. It is source free. Okay, so if that is the case, I need to find the value of you have a formula. Okay, so if it is series, you have the formula is alpha is equal to R divided by 2L. So what is the value of R? R is 9, right? 6 plus 3 is 9, divided by 2 into 0.5. So answer of alpha is 9. So what is omega? Omega is equal to 1 divided by root of LC. What is LC now? Root of 0.5 into 0.02. So that is equal to, if I solve, I will get this is 10. Okay. So here alpha is less than omega. So if alpha is less than omega, it is called as underdamped. Okay. So if alpha is less than omega, sorry, if alpha is greater than omega, it is overdamped. So condition of I of t is this one. So alpha is equal to omega means it is critically damped. So I of t is equal to a1t plus a2 into e power minus alpha t. Alpha is less than omega means it is underdamped condition. So this is what the condition we have derived, and I of t is equal to a1 cos omega d t plus a2 sin omega d t into e power minus alpha t, where omega d is equal to root of omega square minus alpha square, and s is equal to minus alpha plus or minus root of alpha square minus omega square. So this is the condition for series source free RLC circuit. Okay, so this has to be applied for only for this one. Okay, and since it is series RLC circuit, alpha value is equal to R divided by 2L. Okay, so let me go for the same equation. So instead of IT, if I change it for VT means it is called as parallel source free RLC circuit. Okay. So this is a formula. Okay, so here alpha value is equal to 1 divided by 2 R's. So now we are going only for a series source free RLC circuit. So for that one, alpha value is equal to R divided by 2L. Okay. So you can see alpha is less than omega, it is underdamped, so the third will applicable. So first let us find out the value of s is equal to minus 9 plus or minus 9 square minus 10 square. So minus 9 plus or minus 1, sorry, 81 minus 100, that is equal to minus 9 plus or minus j root of 19. Okay, so that is equal to minus 9 plus or minus j, this is 4.359. so this is your omega t. Okay, so here you find out the values. You have to substitute in I of t, right? So I of t is equal to e power minus a1 cos omega dt. Omega dt is 4.359 and a2 sin 4.359 t into e power minus 90. Okay, this is a formula. Okay, so in that you substitute t is equal to 0. So if I substitute t is equal to 0, I of 0 is equal to a1 cos of 0 is 1, right, plus a2 of 0 into e power 0 is 1. So you will get a1 is equal to I of 0 value is 1. Okay, so you can see I of 0 value is 1 amps. Okay, next you have to differentiate this equation I of t. So if I differentiate this equation, so before that you can substitute that value, right? I of t is equal to cos 4.359 t plus a2 sin 4.359 t into e power minus 90. So to find the value of a2, you have to differentiate this I of t, previous equation, that is this one. Okay. So differentiate the fourth equation with respect to time. So di of dt, okay, by t is equal to, so this is a uv formula. Okay, so e power minus 90, I take it common. So now I'm going to differentiate a1 cos 4.359. So you will get 4.359 a1 minus sine 4.359 of t plus a2, because for both equation 4.359 comes, so I taken common. So sine differentiation is cos. Okay, so plus you write the equation that is you now you keep it same, and you differentiate e power minus 90. So you get e power 90 into e power minus 90 into minus 9. So you substitute t is equal to 0. So you will get di of 0 divided by dt, that is equal to, so next this is equal to, this is 1, and sine 0 is 0 and cos 0 is 1, right? So a2 plus this is a1, this is becomes 0, so this is minus 9, right? So we substitute the value as 1, a1 as 1. So we'll get di of 0 divided by dt is equal to 4.359 a2, sorry, minus 9.
One a day. Peter.
Okay. So to find the dA of 0 of dt, so you take the series RLC circuit. Okay, what is this one? You can see 6 and 3 are in series, so you can add these two values, and here I can write this capacitance, I can write it as Vc of 0, and this is 9, and inductor value is 0.5 Henry. So here I of t is common, and so I can write Vc of 0 is equal to 9 into I of 0 plus L di of 0 divided by dt, where L value is 0.5. So Vc of 0 value also you know, that is 6, and I of 0 is 1. So from this I need to find the value of dA of 0 by dt. So dA of 0 by dt is minus 3 into 2, that is minus 6. So you substitute in this formula. So minus 6 plus 9 is 3. So 3 is equal to 4.359 A2, right? So what is the value of A2? A2 is equal to 3 divided by 4.359. So what is 3 divided by 4.359? That is equal to 0.6882. Okay, so substitute in this formula, that is A2. Okay, you will get this equation. So this is your final answer. Okay.